In this video, we will discuss the problem distribute N candies among K people. So the problem previously has been asked in Microsoft. The problem says that there are N candies and the K people are there. So N candies and K people. Now you can understand that we have to find some way to distribute it. So let's see what way has been given. So in the first turn, the first person gets one candy, the second person gets two, and so on till K people. Okay. So there are K people that have been given to us. So if we take this example, so let's suppose n is equal to 7n, okay, and k is equal to 4. So in the first turn, what happens? The first person gets one candy, then n becomes 6. After that, the second person gets two candies, so n becomes 4. After that, the third person gets three candies, and n becomes nothing but 1. Okay, and after that, just one candy is left. So whatever, like the fourth person expects four candies, but since there is just one candy, so we will have to write it. So one candy will be given. So 1, 2, 3, and 1. You can see 1, 2, 3, and 1 because that is how the distribution is done. The first person gets one, the fourth person just gets one candy, whereas fourth person was expecting four candies. And also one more thing we can observe is this is index number 0, this is index number 1, this is index 2, index 3. So basically what is happening, this part is lesser, right? This part of the of this is lesser because basically if you will observe here that the index that is there, if this is the index I, then the value that is expected there is I plus 1. Now let us read the problem statement further. So it says that in the next turn, the person gets k plus 1 candies, the second person gets k plus 2 candies. Okay. So in the next turn, what happens? The next person gets k plus 1 candy, the next person gets k plus 2 candy, the next person gets k plus 3 candies, and then k plus 4 candies, like this. So again, basically, if you will observe the pattern here, so the pattern is nothing but an arithmetic progression. Initially, you were getting 1, 2, 3, 4 candies, then k plus 1, k plus 2, okay, then k plus 3, then k plus 4. So this is what? This is nothing but arithmetic progression, right? This is nothing but arithmetic progression. And now in this part, what we can try to observe is in this that k plus 1 candies, right? After this, if the number of candies is lesser, so we will again do this. Then the person receives the remaining candies and so on. So we have to find the total number of candies every person gets at the end. So we have to do what? We have to find the total number of candies that every person gets. So it can happen like this. Suppose there are k number of people. Okay. Suppose there are k number of people. So in this part, if there are k people, so suppose n value is something, and we fill this part, right? We fill this part like 1, 2, 3, 4 up till k. We fill it. Then what happens? Then suppose that there is a next level. There is a second part. So after that, suppose that we fill that part as well. Okay. So we fill that part. So there will be some levels. There will be some levels like suppose this is level 1, level 2. So there will be some levels that will be completely filled. So we'll keep on traversing and filling it. And then there will be a particular level. There will be a certain level which will not be filled completely. And for that level, we need to check, right? We need to check because for the rest of the parts, it is just an arithmetic progression. And whatever is the left part, we need to do it. So one of the ways to do it could be nothing but a linear search, right? That we basically traverse and then we try to find this answer, right? Then we need to find that what is the total number of candies that every person gets. But instead of doing that, what we can do is we can apply the concept of arithmetic progression that has been given to us. And like you can see, if we apply binary search, then also we can count how much candies every person is getting. But instead, if we use the concept of arithmetic progression and we use the binary search, so we can do what? We can reduce our time complexity from order of n to order of n, order of log n, which will be very lesser. So in this part, we will observe here that basically we will do what? We will have a low, right? We will have nothing but the low and the high values, and we will calculate the mid accordingly. And if till that particular mid, if we are able to get that AP, so if mid is there, so if till mid cross mid plus 1, if we are able to get the answer, right? If we are able to get the answer, because the task is to do what? Task is to find the total number of candies. So basically we want to find as much as possible. So if mid into mid plus 1 by 2, if this is possible, then we will try to change our search space towards the right side, okay, towards the right side. So we'll try to find more, otherwise we will try to find less, right? Because if till mid into mid plus 1 by 2, if till mid it is possible to find a particular sum such that we can get it. So we will try to search in the right side, otherwise we will try to search in the left side. So let us try and have a look at the code so that we can understand better. So we will first of all make an array for all the k people, so that we can show what every person is getting. We will have a low marked as 0, high marked as n, because this is the range, like low is 0 and high as n, that is the number of people. We'll initially have the count as 0, index will be marked as 1, and we will do a binary search to find the sum of the number whose sum is lesser than n. After that, we will calculate the mid and we'll find the sum with that respect to that particular mid, that is nothing but n into n plus 1 divided by 2, that is the formula. We are using binary, like we are using the right shift here to basically divide by 2. After that, if the sum is lesser than equal to n, then I will count the count the number of turns. The number of complete turns that we'll be taking will be nothing but mid by k, and we'll change our binary search towards the right side, that is low is equal to mid plus 1. Otherwise, if it's not lesser than if the sum is not lesser than equal to n, then I need to change my binary search towards the left side, that is nothing but high is equal to mid minus 1, so that I can find a particular mid such that the sum is lesser equal to n. After this part, I'll simply calculate the last, that is for the last segment, how much is left. So that will be nothing but count into k, and I'll subtract, I'll from the overall n, I'll subtract that much particular sum. And once I've done with this part, so now I need to compute what? I need to compute the incomplete last level. So I will say that if some of the n is left, so we will try to distribute it one by one all among the as many people as possible, okay? And if it happens that if it is for a particular ith person, if it is lesser than its requirement, then we will completely assign it and we'll mark n as 0. We will simply terminate out of the loop, and then we'll calculate the contribution for all the k peoples one by one and simply return the answer. Now to do this particular approach, the time complexity will be log n for this particular problem. And since we are also going to use an array which will be of k size, so the space complexity will be order of k. Thank you. Let us discuss the problem coin piles. The problem says that there are n pile of coin and each of the piles containing ai number of coins. So basically the problem says that in this you will be given n piles of coins like a1, a2, a3 up till an, and every pile has mentioned the number of coins in it, right? So like suppose there is a pile with 2, then with 4, then with 1 coin, okay? So this pile has 2 coins, this pile has 4 coins, this pile has 1 coin, okay? So that is what you have been given, and you need to find the minimum number of coins that you need to remove such that the absolute difference between any two piles is at most k. So what we need to do is, we have been given this thing, right? We have been given what? We have been given a1, we have been given a2, okay? We have been given a3, we have been given a4 up till an, okay? And what we need to do is, we need to find two different indexes in this. We need to find one index I and another index j such that I is not equal to j, okay? The index I is not equal to j, I index is not equal to j, and the absolute difference of array of I minus array of j is lesser equal to k, okay? That is the condition in this problem, that basically what you have to do is, I should not be equal to j, and the absolute difference between I and j, between the elements array of I and array of j, should be lesser equal to k. And for doing this, what we can do is, let us have a look at some of the test cases. So let's say if we have been given four piles, okay? Suppose we have been given n is equal to 4, that is 4 piles, and all the piles are like 2, 2, 2 and 2, okay? So in this case, what is the minimum number of coins that you will be required to remove such that absolute value of any two different indexes, array of I and array of j, is lesser equal to k. So in this case, you can see that the answer would be nothing but 0, because if suppose k is equal to 3 has been given, all the difference for all the pairs, the difference is coming out to be nothing but 0, so it is lesser equal to k, okay? Now let us discuss another case that must be given here. So if we discuss this case, so in this case, concept is different, but let us try and discuss one case of our own. Okay, so like so that we can understand the problem clearly. So if I look at this case, let's say 5, 7 and 9. Okay, so in this case what I can do is either I can remove, if I remove one coin from a particular pile. Okay, so in that case I will say that cost plus is equal to 1. I'll add 1 to my cost and this will become 8. This is what I can do. Similarly, if I remove this, if I remove this and make it 6, then one more will get added to the cost. Okay, otherwise there is one more thing that I can do. What I can do is if I have 5, 7 and 6 piles, like if I have the piles, let's say 5, 7 and 9. So what one another thing that I can do is that what I can do is I can have this 5, I can remove this 5 completely, so I can pay cost of 5 and remove it completely. Then it does not become 0, 7 and 9. It does not become like this. Okay, it becomes what? It becomes 7 and 9, because this pile, if a particular pile has been removed completely, so even 0 is not written as its replacement, so it is completely removed, so 7 and 9 will be there. So this is another thing that we can do. Now let us see another case. So if we see a case that is 1, let's say 1, 10 and 7. So if I see in this case, so I feel like sorting, right? Why do I feel like sorting? Because if I have 1, 7 and 10, so in this case I can easily observe that if I keep a pointer on the largest guy and a pointer on the slope on the largest and the smallest guy, and if I try to minimize the difference between the maximum and the minimum every time, then maybe I can try to get something. But still it does not work properly, right? We might have end up having a lot of time complexity. So in this case what we can easily observe is that what we will do is, first of all, sorting is kind of required. Okay, sorting is required if we try to minimize the difference. Now if we try to minimize the difference between the largest and the smallest, then we can maybe get to some conclusions. Apart from this, let us say that what we have been given is, we have been given 1, 7 and 10. Okay, suppose that we have been given 1, 7 and 10, and we have been given the k value here as 3. Okay, so in this case what we can easily try and observe is that the difference between 1 and 10, right, in the difference is actually 9. So I need to reduce it. So I need to reduce this 10 by a lot so that I can get it. So basically I need to reduce this 10 to nothing but what? I need to reduce it to 4. That means I'm paying what? I'm paying a cost of 6 to reduce it to 4. Then for this 7, the difference currently is coming out to be 6. So I need to reduce it. So therefore for doing this, what I need to make it is 3. Okay, such that the difference like can minimize. So again I need to pay some cost. Okay, so if I'm paying so much cost, so it like if I'm paying so much cost such that I can bear it, so it will take a lot of cost overall. But instead of doing this, you can see it will take cost greater than 6 actually. But if I do what, if you give me k is equal to 3 and I remove this starting guy, if I remove the smallest guy, suppose that I remove the smallest guy, so in that case what happens, it will look like 7 comma 10. And now you can see that 7 comma 10, the difference between the two is lesser equal to 3, right? It's basically what, it's lesser equal to k, that is it's lesser equal to 3. So in that case I can say what, in that case I can say that I can just pay a cost of 1, I can do it. So in this way you can observe that basically every time what I can do is, if I have the array as sorted, so I can try to remove the minimum, like I can try to have 7 as the minimum and remove every other guy before it, so that I can get this thing. Okay, so if I had 1, 7 and 10, so I'm currently considering if 7 as the minimum, so all the elements before 7 that are that are lesser than it, they will get removed. Okay, now let us try and have a look at this example. So suppose this point file that is there, it will be given in unsorted manner, but then after that I will sort it as well. Okay, so suppose this particular coin file has been given to me, and I want to see what happens when my minimum coin file is, let's say, if I say that my minimum coin file is this thing is 10. Okay, so if this is my minimum, okay, this is my minimum, so in that case this will be array of I. Okay, so what will be the higher value? The higher value will be, let's say, array of I plus k. If minimum that I can like if there is a minimum that I can afford, that is array of I, so the maximum I can go till where, if the difference between the smallest value and the largest value can be can be k only, so array of I plus k will be the largest value. So in that case you will say 13 will be the largest value, right? Suppose if k value is 3. So then in that case what I need to do is, first of all I need to remove this part, right? I need to remove the smaller part. So a cost of 3 for doing this. then what I need to do is I need to subtract 13 from this, 13 from this, 13 from this. So every time if I keep on subtracting, so this will be 3, this will be 6, this will be what? This will be 12. Then I need to add them up. So this will give me 21, 21 plus 3 will give me 24. So it is taking a lot of cost, you can see. So like in this case, if you observe again, so suppose what I do is instead of this 10, now what I want to do is I want to make this 12 as the new minimum, right? If I want to make it as the minimum, so if I make it arrow 5 and I make 15 as arrow 5 plus k, right? If arrow 5 plus k then becomes 15 automatically. In that case, I have to remove this much static segment, because if I will remove it, only then 12 will become the minimum element. So that means 13 for removing, and then after that, like whatever is the maximum limit, and whichever elements are greater than the maximum, so I need to subtract 15 from each of them, right? So basically in this case, I can I if I do it, so I have to iterate every time, and it will take a lot of time. So it will be kind of order of n square approach in nature. So what I can instead do is, if I want to remove this much part, right? So I can get reminded about a concept that is nothing but the prefix sum concept here. So what I can do in the prefix sum concept is, I can basically say that I'll calculate the prefix sum. So what do I mean by that? So let's say I'll have a prefix array that will calculate the prefix sum. So this will be 3, this will be 13, this will be what, 25, this will be nothing but 41, this will be 60, and this will be 85. Okay, now if I want to remove till this part, okay, so I can say that prefix of I will tell me that 13, if I remove till this index, then 13 will be removed. Okay, so that is one of the advantages. So suppose this is the minimum that is there. So if I want to remove till here, so this part I will remove here, right? Now the next part is that what is the upper bound, right? What is the upper bound? So basically now in this case, if I see, so if array of I is equal to 10, okay, if my array of I is equal to 10, if the minimum value that I am considering is 10, so what is array of I plus k? The largest difference I can have is k. So that means the largest value that I can have is nothing but array of I plus k. So this, suppose if k value is 3 here, so it will be 13 here. If k value is 3. Okay, now you need to subtract 13 from this, 13 from this, 13 from this. So if you do it again and again, it will take a lot of time. So basically what I can try to do is, I can try to use the prefix sum concept here, and I know that if I want the sum of this range, so sum of this range will be nothing but it will be stored in prefix of n minus 1. Okay, prefix of n minus 1 minus what, prefix of this thing, prefix let's say what is this index. So I need to do what, I need to find the index, this index which is just greater, the I need to find the, I need to do a binary search, and I need to find the upper bound index. The upper bound index, that is the index that is just greater than array of I plus k. If I find it and I subtract it, so p of n minus 1 minus p of index minus 1. Okay, so if I subtract this much part, so I'll get the sum of this much range. But do I want the sum of this much range? No. In from this particular sum range, what I want to subtract is, I want to subtract array of I plus k. Okay, I want to subtract array of 5 plus k from every element. So the number of elements is nothing but n minus index. Okay, so the overall answer will be what? Overall answer will be prefix of I minus 1 plus prefix of n minus 1 minus prefix of index minus n of n minus index into array of I plus k. So that is what will be happening here. So suppose in this case also one more thing that can happen is, suppose it is 5, then it is 10, then it is 10. Okay, so I'll write it. Suppose it is 3, then 5, then 10, and then 14, then 15, and then 15, and then 17. So in this case, if one time if I consider this as minimum, so I'll not consider 10 as minimum again. Similarly, if I consider 15, so I'll not consider 15 as minimum again. So okay, so this is one thing more important that we need to consider. Now this will be the approach. So basically the answer will be what? The answer will be nothing but prefix of I, that is still the ith index if I want to remove them, and then prefix of that is nothing but n minus 1, like prefix of it will be nothing but prefix of I minus 1, you can say, plus prefix of n minus 1 minus prefix of index minus 1, where index is found with the help of the binary search. Okay, I'll find the index using the binary search. Okay, and then what do I subtract from it? I subtract n minus index into array of I plus k, that is the largest value here. Okay, that is what I would do. So let us now write the code for this particular approach and see what will happen here. So basically what we would be doing here is, we will say that we need to sort the array first of all. So sort a comma a plus n. So I'll declare the array as a small and n as a small 2, so that we can be quite quick with this. Okay, so I have the array, I have the n, and I have the array. Okay, So after I have sorted it, so what I will do is I will have the prefix sum initially for all the n indexes. So I'll say that prefix of 0 is equal to 0, is equal to array of 0, that is the first element, and then I'll iterate. So for int I starts from 1, I is lesser than n, then I plus plus, and then I'll calculate the prefix sum. So prefix of I is equal to nothing but prefix of I minus 1 plus a of I, right? That is how I'll add the prefix sum. Once I have added the prefix sum, so what do I need to see? So I need to see that what is the minimum result. So I'll say that initially the maximum, initially I'll mark the result as maximum, because I need to mark the result as maximum because I want to find the minimum result. So initially I'll consider that the result is positive infinity. Okay, and here I need one more thing, but I'll first of all iterate. So what I need to say is that for int I starts from 0, I is lesser than n, then I plus plus. Okay, I'll iterate for all the indexes, and what I will do is first of all I'll find the index. So index is equal to nothing but upper index is the first element which is just greater than array of I plus k. Index of the first element which is just greater than array of I plus k, that will be nothing but I'll be iterating from a comma a plus n, and I'll find which is the element which is just greater than array of I plus k. So once I have found its index, so what will I do after that? So after I have founded this index, so I can say that result is equal to nothing but minimum of what? Result comma, you can say this thing, minimum of result comma p of I minus 1 plus p of n minus 1 minus p of index minus 1. Okay, and then what I will do is then subtracting from this part. So I'll take this in a bracket. This is the overall sum of that particular range which is greater than array of I plus k. So I don't want to remove this much complete elements. I just want to remove the trim the part which is just greater than array of I plus k. So I'll say that since n elements are there and n minus index elements are there, so from all those elements, what I need to subtract is I need to subtract array of I plus k part, right? This is what I need to overall subtract from them. So I will simply subtract this much part from them, and then I can say that I can possibly return the result in. Okay, that is what I would do. But still, this part is not sufficient because, as I mentioned, that if there are duplicates, then we have to check for those conditions as well. So for this, what I will do is I will have a int start variable. Okay, that will be nothing but the starting values that I will be storing in it. So start in initially 0, and then what we need to do is we need to say that if the I part is greater than 0. Okay, so if I'm having indexes, because for the first guy I'll always checking. So if I is greater than 0, okay, and it happens that array of I is let's say not equal to array of I plus 1. So if I and the I plus 1 guy are not the same, if they are the same, then I will not do this thing. If they are not the same, then I'll say that start value is equal to nothing but p of I minus 1. Okay, I'll update it, and then here also I'll say I'll instead of p of I minus 1, I'll directly write the start so that I can get this much part. Now let us try and compile this to see if it can work here. Basically that part was for removing the reversals. We are getting some compilation issues, so it is saying that index. Okay, so I need to write it as int. Okay, now let us try and compile to see if there is any other error that I might have made. Okay, another error is there. So it is saying that ARR. Okay, so instead of ARR, I should use A because the array name is A. Now I think it should work fine on samples. Okay, so it seems to work on the samples. Let us try and submit this code as well. Okay, so we are getting a wrong answer. I don't know why. So let me just check this part. So basically what we have done is we have iterated. So we have sorted it. Then int p of n, p of 0 is equal to 0, and then I iterate, marking the result as int max and starting value I have marked as 0. Okay, and after that I iterate. I find the upper bound of a comma a plus n and a of I plus k if my ith element is there, and if it happens that I is greater than if I is greater than 0 and a of I is not equal to a of I minus 1, then in this part the start value I'll mark as p of I minus 1, and the result will be nothing but start plus p of n minus 1 minus p of index minus n minus index into array of I plus k. Okay, so this part also seems to be correct, and then I will simply return the result. Okay, so that is what we are trying to achieve here. So let me check if I have made any mistakes. So if this part is correct, and the summation will be nothing but this much. I'll store the result, and after this part is done, so we need to simply iterate to it, and then we need to check for the upper bound. So in that condition, we have the start value and we have this thing. Now this part is getting subtracted from it as well. So I don't think I'm making any mistake in this part as well, right? Uh, okay, let us try and submit it again to see if there's any error. So we are getting basically the answer. If you see in this part, so we are getting what we are getting. Its correct output is 10, whereas we are just getting 8. So we are not able to add properly, I think, right? So I have sorted the array first of all, array, and then I have p of n, p of 0 is initialized to 0, then I iterate from I starts from 1 in this part, and then I do it. So instead of doing this, what I can maybe do is, if instead of this part, what I can have is, like, let's say, if I just have p of I minus 1, then I think it would work here. Let's try and compile this. So have I not done index minus 1? I have done this thing as well. So it also seems fine. Let us try and submit this. Yeah, so now it got passed. So it was able to pass all the test cases there. Now talking about the time complexity of this code. So the time complexity for this code is going to be nothing but order of n log n, because we are using a binary search approach, and since we are building a prefix array, so space complexity will be order of n. And talking about the homework problems, so the first problem is nothing but square root of a number. In this we will be given a number x and we need to find the square root of x, so you can apply binary search and do that. Then another problem is killing spree. In this what you have to do is, there are infinite people standing in a row from index 1, and a person having index I has the strength I cross I. So your strength is p. You need to tell what is the maximum number of people that can be killed by your strength p. And now talking about another problem, that is bike racing. So this is also a simple implementation of binary search, where we have to change our left and the right, low and the high according to the parameters. So you can try this problem out as well. Thank you.